all, let us discuss question number 41 of grade 2015 chemistry. Question is, the rotational partition function of a diatomic molecule with energy levels corresponding to J is equal to 0 and J is equal to 1 is, where they have given epsilon is a constant. Options given are 1 plus e raised to minus 2 epsilon, 1 plus 3 e raised to minus 2 epsilon, 1 plus e raised to minus 3 epsilon and 1 plus 3 e raised to minus 3 epsilon. Here, the information given are, we have to find out the rotational partition function when J is equal to 0 and J is equal to 1, and they have given epsilon as a constant. Keep in mind these three things. Before solving this question, you must understand what is a partition function. Partition function is a function which is associated to the way particles are partitioned among different energy levels. You must be known about Boltzmann distribution. According to Boltzmann distribution, Ni divided by N is equal to G e raised to minus beta Ei divided by sigma G e raised to minus beta Ei. This denominator part, which is sigma G e raised to minus beta Ei, is called as the partition function, and the capital Ni, which is total number of particles in a particular level, and N is the total number of particles. Here you can see a value G, which is the degeneracy. This degeneracy will be different in the case of rotational partition function and vibrational partition function. In the case of rotational partition function, degeneracy G will be equal to 2J plus 1, where J is the rotational quantum number and energy is equal to Bj into J plus 1, where B is the rotational constant and J, as I already told you, is the rotational quantum number. For vibrational partition function, since all the energy levels are singly degenerate, G value will be equal to 1 and the energy, as you already know, energy is V plus half into HQ, where V is the vibrational quantum number. No need to remember this vibrational partition function since our question is rotational partition function. So you have to keep in mind this G value for rotational partition function, which is 2J plus 1 and energy is Bj into J plus 1. Now let us solve this particular question. We know that partition function, let us take that as Q. Q is equal to sigma G into e raised to minus beta Ei, where beta is equal to 1 by kT, where K is the Boltzmann constant and T is the temperature. No need to solve this one for this particular question. Now let us see when J is equal to 0, the G value for rotational partition function, it will be 2J plus 1. So when J is equal to 0, 2J plus 1 will be equal to 2 into 0 plus 1, that is equal to 1. Okay, now Ei will be equal to Bj into J plus 1, that will be equal to B into 0 plus 1, that will be 0. Now, when J is equal to 1, what will be 2J plus 1? This will be equal to 2 into 1 plus 1. 2 plus 1 is equal to 3 and the energy Ei is equal to B into J plus 1. This is equal to B into 1 plus 1. That is equal to 2B. Now let us apply in partition function Q rotational is equal to sigma G into e raised to minus beta Ei. The first part is when J is equal to 0, it will be 1 into e raised to 0 plus when J is equal to 1, it is 3 into e raised to minus 2b into beta. In the question, they have given this as a constant epsilon. So this will be equal to 1 plus 3 e raised to minus 2 epsilon. So this is the rotational partition function when j is equal to 0 and j is equal to 1, which is equal to 1 plus 3 e raised to minus 2 epsilon. Now let us see the options. Option A was 1 plus e raised to minus 2 epsilon. This is not the answer. Option B is 1 plus 3 e raised to minus 2 epsilon. This is the answer we got. And the third option was 1 plus e raised to minus 3 epsilon, which is not. And fourth one was 1 plus 3 e raised to minus 3 epsilon. This is also not the correct answer. So the correct answer of this question is answer B, 1 plus 3 e raised to minus 2 epsilon. For further information, you can go and check this NPTEL reference. Lecture 14, Macroscopic and Microscopic States, Boltzmann Distribution, Canonical Partition Function by Professor Sandeep Paul from IIT Guwahati. This is the corresponding YouTube link. Thank you.